Okay, get your notebooks out, please, and we are going to take notes on dot products. Page 25, dot products. And I believe this is the last day we're taking notes in these notebooks this year.
Hey, bless.
Next semester we'll start off in here. But I think this is it. This was pre-cal, but yes, next semester in Lone Star, it is pre-cal. But you'll see that is Algebra 2.5. It's just going over Algebra 2. Yeah, in the beginning, when we do polar graphing, yeah. Once polar graphing is up and we start functions, yeah, we're done with the unit circle. Alright, if y'all can silence. And we are going to do 5 examples today. Maybe 6 if I can get to it. So, today we're going to be talking about dot product and its uses. So the first thing I need you to know is given 2 vectors. So given vector v, which is a vector I plus v vector j, and vector w, which is c vector I plus d vector j, then the dot product of vector v dot vector w is the product of your x components plus the product of your y components. Now remember, before the break, we learned that you can write it like this in linear combination form, or you could write it like this. They are the same thing, right? So you would multiply a times c plus b times d. And for dot product, it is a scalar product. You are just getting a number. Not a vector, you're just getting a number. So here is example 1. If vector v is 2 vector I minus 3 vector j, and vector w is 5 vector I plus 4 vector j, I want you to find vector v dot vector w. So what am I going to do? Yeah, just say it. Okay, give me how you do it first. 2 times 5 plus negative 3 times 4. And do y'all agree that is 10 plus negative 12? Which is negative 2. And that's your dot product. That's it. Now, why do people get this wrong sometimes? They do a times b plus c times d. Don't do that. You do your x components and your y components. Okay? Questions? What if I ask for the dot product of vector v times times vector v? I would just do 2 times 2 plus, you do it twice, right? Or, what did you say back there? Square it. Couldn't I say 2 squared plus negative 3 squared? which is 13. Where have we seen this? The magnitude. What's magnitude? The distance. Don't you agree that's just your x component squared plus your y component squared? Now, when we do the magnitude, remember it's the square root of those. So it's the square root of 13. So your dot product is just your magnitude squared. And we'll write that down formally. But that's where dot product comes and how it is related. Do I have any questions? Now some properties of dot products. There are 4 of them I want you to know. The first one is that it is commutative. You learned this word in geometry. Does anybody remember, what commutative is? You learned it during proofs. Vector v dot vector w is equivalent to backwards w dot vector v. Meaning you could switch them around and you'd still get the same answer. 4 times 5 is the same thing as 5 times 4. So if I would have said vector w dot vector v, you would have gotten the same thing. Okay? Dot product is also distributive. So if I have vector u dot vector v plus vector w, I can distribute that vector u and do vector u dot vector v plus vector u dot vector w. And then we said this earlier, but what if you take the dot product of itself? The magnitude squared. Last but not least, this one we don't use a lot, but I hope it's common sense. What is 0 dot vector v? 0. So just something I want you to know. Do I have any questions? I see a couple people writing, so I will wait. Now, why do we use dot product? What is its purpose to us? Well, one of the ways we use it is for the magnitude. But the other way we use it is for the angle between two vectors. So if you have two vectors that share a common endpoint, then there exists an angle between them, and we're going to call it theta. Now some things I need you to know about theta is that theta is going to be between 0 and 180 degrees. So when you are doing, you're going to use your calculator for this, you need to make sure you are in degree mode. And the formula you're going to use to find theta is the cosine of theta is the dot product of vector v dot vector w over their magnitudes. You are going to have this memorized. Most of you will by the end of today. You are going to multiply their magnitudes, yes. What else? All right, so let's do example 2. Can you see that? Find the angle between 4 vector I minus 3 vector j, and vector w is 2 vector I plus 5 vector j. What am I going to need to do here? Find the dot product. What else? And what else? And the magnitudes. So how do you find dot product again? And that's going to give me 8 minus 15, which is negative 7. How do we find magnitudes? Square root of x squared plus y squared, or x component plus y component. Questions? Am I done? No. What do I need to do? Now I'm going to plug it into the equation. The cosine of theta equals the dot product over the two magnitudes. And you're multiplying them. Before I go on, what does your brain tell you to do next? Rationalize. You do not have to rationalize on these. Why? Because we're just plugging into the calculator. So what is our actual next step? inverse trig, inverse cosine to find theta. So theta is the inverse cosine of negative 7 over 5 square roots of 29. You could rationalize. There's absolutely nothing wrong with it. You just don't need to. Now be careful. What do you have to do? Degree mode. Make sure you're in degree mode. And then we are going to do the inverse cosine of negative 7 over 5 square roots of 29. What is our answer? 105.1. And I would like you to, next to that, write therefore neither. Alright, why did we write therefore neither? I don't know. We haven't taught you it yet, but I'm about to. If you have room, you can keep writing. I'm going to go to the back. Is everybody okay with me moving problems? Alright, so the reason we wrote neither is because there are two special types of vectors. We learned 2 Wednesdays ago. You remember 2 Wednesdays ago? We learned 2 Wednesdays ago that there are parallel vectors. What are parallel vectors? Does anybody remember? It's when you have two vectors that don't necessarily have the same magnitude. They can, but they are the same direction. Or they can go different directions. And if they go the same direction or different directions, if they're parallel, then the angle between vector v and vector w is what? What's the angle between these two vectors right here? 0. They don't have an angle between them, right? They're on top of each other. Or, what's the angle between these two vectors here? They make a line 180 degrees. So parallel vectors have an angle that is 0 or 180. Was that last problem we did parallel? No, because what was my angle? 105.1. That's not parallel. That's why we put neither. What is the other special situation that we usually have with degrees? A 90 degrees. And what would 90 degrees be? It's actually not. I looked it up last year because somebody asked and I didn't have an answer, so I Googled it. And my answer was the book has it written this way, so that's why we do it. They don't use the word perpendicular. They use the word orthogonal. Can everybody say orthogonal? Orthogonal vectors are just perpendicular vectors. And so the angle between vector v and vector w would be what? 90 degrees. If it is orthogonal, the angle between is 90 degrees. So you can write below it perpendicular. The question's literally going to ask you, is it parallel, orthogonal, or neither? So I've had a couple people say, Ms. Alvarez, can I just write perpendicular? No, answer the question. So write orthogonal. But it'll be there for you. Like, it's not like you have to make it come out of thin air. Does that make sense? So let's do example 3. Find the angle between. What am I going to have to do? How do I find the angle between? Three things. What's the first thing? The dot product. What's the second thing? The magnitude. And the third thing is the other magnitude. Do those three things. And then what? I'm perfectly okay with you just straight going into theta equals. What is theta going to equal here? Be careful, the what? Inverse cosine of. Did anybody notice I did not simplify that second radical? Could you simplify it? Sure. There's nothing wrong with simplifying this to be 2 square roots of 10. But do you have to? No, because we're just typing it into the equation. Inverse cosine 20. Nope, that was too much. And what do we get as our answer? Okay, don't just put 0 though. Put 0.0 because that lets me know like it wasn't exact, it was a roundabout answer. So this is theta equals 0.0 degrees. Therefore, what is the angle, what do we know about the angle between these two? Say it again. The parallel vectors. Does that make sense? Can everybody look up? Can you look at these two vectors? What do you notice about these two vectors? Say it again. They're what? They're proportional. They're just doubled. Do you agree we took these two numbers and doubled both of them? That will always happen if they're parallel and 0 degrees. So, you could say, instead of doing all this work, you could say they're parallel because vector W is 2 times vector V. And that would work. So if you notice that they're proportional, that you can just multiply, you can skip all this and just say this. Okay? If you don't notice, well then you just get a little bit of extra work. It's not too bad. All right. Example 4. Find theta if v equals 2 vector I minus j and w equals 3 vector I plus 6 vector j. Go. Same steps. Did y'all get the square root of 45 for the other one? Okay. And when you put this in the calculator, before you do that, did y'all get 0 for the dot product? 0 divided by anything is what? 0. What is the inverse cosine of 0? Where is cosine 0? At 90 degrees. Or pi over 2, but we're going to do everything in degrees, at 90 degrees. Therefore, this is orthogonal. Or these are orthogonal. Now, did you have to do all this to prove they were orthogonal? No, because anytime you end up with 0 at the top, don't you agree you're going to get the inverse cosine of 0? Which is always going to be. So what you could do is you could stop right here and say orthogonal because the dot product equals 0. That is an easier, faster way to do this. And then if they're not 0, 90, or 180, what is your answer? Neither, and you would just do this. All right, I'm going to give you a minute to write these down and then 2 minutes to do them, and then we'll be done for the day. These are example 5. Are these parallel, orthogonal, or neither? Are they parallel, orthogonal, or neither? And state why. All right, what about this first one? What do we think? Why is it orthogonal? It is orthogonal because vector v dot vector w equals 0. What about the second one? Why are these parallel? Because vector w equals what? 4 times vector v. And there you go. All right. Tomorrow you have a quiz. Don't forget to study day 1 and day 2 notes.